Assalamualaikum warahmatullahi. My name is Muhammad Azwan bin Hussein. For this project, I will present the chapter 1 for the introduction. For the introduction, the principle of the application for the microphone or how sound pass through a microphone will be covered in the next chapter. The industry use of the microphone and scope are included in this chapter as well as the project school. The scope and development schedule. For the principle of application, electronic gadget called microphone convert sound into electrical current. Diaphragm vibrate in response to the sound wave, which is in turn cause a magnet that is close to the coil to move. In other arrangement, the coil is unrestricted inside the magnet. Okay, for the industrial application, the metrologists are used to listen in on conversation for security surveillance and espionage purpose. They are also used by individual, the police, security agents of intelligence, and country intelligence. The objective is to locate and identify the suspect as well as learn more about their whereabouts. Okay, that's all for me. Thank you.
So, Assalamualaikum. My name is Irfan Ishad bin Shukami and my metric number is MA19132. So, today I'm going to present on chapter 1, which is the instrumental system. Okay, so instrumental system consists of 4 elements, which is the first one is the sensing element, which is in this project we use the microphone, and the second one is the signal conditioning system and signal processing element, which is the element that we do process in software that we use, which is the DesiLab. And the last one will be a data presenting element, which is we interpret all the data, all the sound that we going through to the software, is we present it into graph. And also our objective for this project is to study the sound wave of a hair clipper and to translate the signal into time domain and frequency domain, and to represent sound value on DesiLab and PhoneApp, which we will compare between DesiLab and PhoneApp. So what is our scope for this project? Okay, the first one will be the sound wave will be generated by hair clipper, and the sound wave will be detected by microphone. And next, the sound wave will be analyzed by this software, and when we get the value, and the value will compare with by using the DesiLab and software and smartphone app. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hilmi bin Jemain and my matrix number MA20036. Today I will explain about the literature review for this report. For the literature review, we have acoustic measurement and instrumentation. The acoustic measurement, also known as physical measurement, also known as physical measurement that characterize acoustic phenomena in critical in engineering tasks such as product design, production testing, machine performance, and process control. Acoustic measurement necessitates the installation of both software and hardware. The transducer properties are significant for an acoustic measurement because they influence the value of parameters acquired from the voice specimen. Signal conditioning guarantees that the analog signal from the microphone are prepared before being transformed to digital form. For the microphone, in condenser microphone, a lightweight membrane and fixed plate serve as opposing side of a capacitor. Sound pressure such as movement of this thin polymer sheet. This movement changes the capacitors of the circuit. resulting in fluctuating electrical output. Condenser microphone can also handle high sound pressure level. They can endure loud instruments such as drums. Although less Although less sensitive than a condenser microphone, dynamic microphone is essential when recording an instrument or speech with a large dynamic range or that is excessively loud. Because of its lesser sensitivity, it picks up less unwanted ambient noise, make this microphone a better choice. Next, for the frequency response, condenser and ribbon microphone had great frequency response across the nominal range of human being, which is 20 Hz to 20 kHz. But dynamic microphone have a frequency response of 50 Hz to 15 kHz. The direction of the acoustic source of the on the microphone membrane influence the frequency response need the orientation of the microphone. That's all for me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So today I will present the chapter 3, which is the methodology for our project. Okay, next for the material and equipment that we use in our project is hair clipper as the source of the sound for the acoustic measurement. And next we use laptop, which has a Desilat in it to record the sound measurement. And next we use the Desilat software itself to record the time and frequency domain. And the last one is sound meter app to obtain the average decibel in our hair clipper. Okay, next. Okay, for the Desilat setup, first the measuring setup will be set up at 10 kHz with a block size of 12 to 20,000. Okay, next, first and foremost, to achieve accurate formula computation, the input will be served as the primary reference item, and it's important to ensure that the input value is accurate. Okay, next, for the Desilat setup, the sound meter app, which will be used as a dB meter, will be installed in our phone so that we can verify the actual or reference decibel for the hair clipper that we use for our project. Next, the value that we obtain from the input will be inserted to the formula and the outcome will be calculated. Okay, so here is the input that we have from the dB, the sound meter. Okay, the reading in dB sound meter is 52 on average, and the Desilat reading is 0.14 volt in peak. Thus, the value that we obtain, we will be substitute into the formula, which is the dB equal to 20 log 10 V over V reference. So from that equation, after substitution and calculation, we will get the VREF, which is 0.0003516664. So the VREF will be inserted again to the original formula, and the final formula will be dB equal to log 10 input V or divided by 0.0003516664. And for the last step, the sound step will be repeated in Desilat with the correct formula, and the dB level, the decibel level, will be recorded on the smartphone, and the result will be screenshot on a laptop and used in the project result and discussion. I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Hafizi bin Madrani. My matric ID MA20183, and I will discuss about the result and discussion. This is the result that we get from the sound of hair clipper by using the Desilat. For the RMS value, the value is 0.14 volt, and for the decibel value, the value is 52 decibel, and this is the time domain graph. And based on this graph, it shows that the peak value is 5.9 volt. And this is the value from average decibel from the sound meter app, and it shows The value is 52 decibel. Next is discussion. In this figure, it displays that the voltage fluctuation from negative 7.5 volt to 7.5 volt over time. The graph displays the maximum and minimum voltage with time amplitudes. It can be demonstrated that the change in audio frequency have no effect on amplitude. Based on the results achieved, the average decibel reading from the sound meter app on a smartphone and the reading from the DesiLab software both show the same reading, which is 52 decibel. Therefore, we can assume that the two values obtained from DesiLab software and the sound meter app are accurate and precise, considering that the error percentage is 0%. However, this data may be slightly different if it done in different places and device. This is due to several factors that interfere when the reading value is taken. For example, the environmental noise factor and the accuracy factor of the device used. As a conclusion, in this project, we have gained knowledge on how to use DesiLab software, which will be immensely useful. The underlying principles involving measurement and instrumentation methods are now properly understood. To do this project, we utilize our subject knowledge. This project is significant because it requires us to use formulas to calculate decibels level, which enables us to put what we have learned in class this semester to use. And lastly, because this task was complete at home, there may be some disruption or inaccuracies. Environmental noise could be the source of the disturbance. To prevent environmental noise, it is advised that this project be carried out in a limited space, such as laboratory. This experiment also revealed how to construct a system for analyzing and understanding time and frequency domain signals. That's all from us. Thank you.